Okay, number one, let's take a look at this one. What we've got here is a binomial now. It's a cubic, and so notice 8 x cubed and then 1 both would be perfect cubes. So I've got a sum of perfect cubes. So we can solve this one by factoring, and in fact every equation here on this review is solved by some sort of factoring or another. Now, so let's recall how to factor a sum of cubes here. So I'm going to take the cube roots of both 8x cubed and 1. So that's going to give me 2x and then plus 1. And now for the trinomial part, we'll take 2x and square it. So that'll give me 4x squared. And then I'm going to look at the opposite product there for the middle term would be negative 2x. And then my 1 squared there would be 1. Now, the second trinomial there is not going to factor, so I'm going to have to solve it somehow. Now, the first binomial factor, that one gives me an easy solution there. So what makes this first factor 0 there would be negative 1/2. Now, for my other one, again, it's not going to factor. It's not a perfect square trinomial. So I'm going to have to complete the square or do the quadratic formula. Now, I do have an even linear term there, but notice we've got a leading coefficient. So completing the square is going to be too rough here. Let's just use the quadratic formula. So let's do b squared minus 4ac to find my discriminant there. And so that's going to give me 4 minus 4 times 1. And so I'm going to have 4 minus, that would be negative 16. And so that will give me negative 12. Okay, now let's put it in our quadratic formula. So we're going to get opposite of b plus or minus the square root of that discriminant over 2a. So opposite of b, that's going to be a positive 2 plus or minus. Now, the square root of my discriminant, if I can do the square root of that, I would simplify it by using negative 4 times 3. And so it would simplify to 2i squared of 3 over now 2 times 4 there would be 8. All right, so notice I can reduce this by a factor of 2. So I'm going to get 1 plus or minus I squared of 3 over 4. And notice we've said here from the second factor, that trinomial, the two solutions that we would get from that would be imaginary. And so I got 2 imaginary solutions there and 1 real solution from the easy binomial factor. Okay, number 2, another very similar problem here. This is just a difference of cubes. So my cube roots are going to give me x and 5. So I'm going to have x minus 5. Now, the first one's squared, x squared. The opposite product would be positive 5x. And then negative 5 squared would be positive 25. And so again, that binomial factor is going to give me an easy solution of just 5. So let's concentrate on this quadratic one now. So that quadratic, notice, it's not going to factor. It never does on a difference of cubes or a sum of cubes. And so 5 is odd. So I'm going to use the quadratic formula here again. So b squared minus 4ac, that will give me 25 minus 4 times 1 times 25. And so that's going to give me a negative there. That would be negative 100. 25 minus 100 would give me negative 75. Now let's put it in our quadratic formula. So opposite of b plus or minus the square root of that over 2a. So opposite of b, that would be negative 5 plus or minus. Now the square root of negative 75 can be simplified by using negative 25 times 3. And so that would simplify to 5i square root of 3 over 2a. 2 times 1 would be 2 there. That one's not going to reduce. So I've got those 2 imaginary solutions there and the 1 real solution there. Okay, number 3, now we've sort of changed gears. So this is not a cubic. Now we're down or looking at up to a quartic. Now, so we've used the expression here for this one that this is quadratic like. And so I can factor it like a quadratic with the exception that my factors are going to have squares on them. So we can factor it just a little backwards method. Factors of 18 that add to give me 7 would be 9 and 2. But there again, since it's not a quadratic, it's a quartic instead, these are going to be x squares instead of just x's. All right, both signs are the same and both are minus. Now the other thing that's different from a quadratic is now what I could possibly have is one of the two factors could possibly be a difference of squares. So notice the first one there, x squared minus 9. That is a difference of squares. So I could factor that as x plus 3 times x minus 3. Now the second factor, x squared minus 2, 2 is not a perfect square. So that one's not going to factor again. I'm just going to bring him down. Now, let's see what makes them 0. So negative 3 would make that one 0. Positive 3 would make that one 0. So we have solutions of plus or minus 3. Now, what makes this 0, I'm not going to say that. I'm going to actually set it equal to 0 and see. I want to be really careful with the squared factors. Now, I'm going to add 2 to the other side. So they make that positive 2, and now I'll just take the square root. And so x is just going to be plus or minus the square root of 2. That's not going to simplify there. So I've got 2 sort of irrational answers and then 2 rational answers. They're all real there, by the way. Okay, number 4. Now this one is also a quartic, so we can treat it quadratic-like. Now it's different in the fact, look back at number 3. 3, it was a trinomial. Now this is a binomial. So the way I have to look at this is a difference of squares. So this would factor to x squared minus 6 times x squared plus 6. Now, let's look at those two factors and let's see, is one of those possibly a difference of squares? This one is certainly not because it's plus there, but this one is a difference, but 6 is not a perfect square. So I can't factor anymore from this point. So I'm just going to set both of them equal to 0 and solve now. And so I'll add 6 to this side here. And so that's going to give me a positive 6. We take the square root. 6 can't be simplified. So this is just going to give me plus or minus square root of 6. Over here, the only difference in the solution now is when I subtract 6 here, or I'd subtract 6 here, and so it's negative 6. And so I'm going to do square root on both sides now. And so that's going to give me plus or minus I square root of 6 because that one's negative. Okay, number 5, this one's similar to number 4. Again, it's a difference of squares, but it's a quartic one, so my factors are going to have x squares on them. So x squared minus 9 times x squared plus 9. Now, let's notice in this case that that first one, that's a difference of squares, so that can be factored again. So I could write that as x plus 3 times x minus 3. But the other one, x squared plus 9, that's not a difference. So that cannot be factored. So I'm just going to bring that one down. And so now the solutions here that I get that make them 0, the first one is negative 3, the second one's going to be positive 3. So I have plus or minus 3. And then this one, I'm going to take my time on it. I'm not going to try to do it in my head and see what makes it 0. Let's set it equal to 0 and see what makes it 0. So I'd subtract 9 to the right side here, so it's going to give me negative 9. And now we'll take the square root of both sides there. And so that's actually going to be imaginary. It'll be plus or minus 3i. Okay, number 6. Now we're back to a quartic. We're still at a quartic, but now we're back to 3 terms. So this is a trinomial one. This is not a difference of squares. We're just going to do that backwards factoring thing. So we look at factors of 10 that subtract to be 3 would be 5 and 2. So there again, 5 and 2, but my x's are going to be squared here because this is a quartic. Okay, sign rules. We've got that negative 10 there, so signs are going to be different. And that first minus sign is going to go on the bigger number, so minus 5 and plus 2. So I'm noticing neither one of these are differences of squares, so I can't factor them anymore. So I'm just going to set both of them equal to 0. So an add 5 here to the right side, that's going to give me a positive 5. And we'll take the square root. So that won't simplify. That'll just be plus or minus the square root of 5. Okay, over here we're going to subtract 2, so that's going to make that negative 2. And so when we take the square root of negative 2 here, that's going to be plus or minus I square root of 2. Okay, on 6, now notice this one's a little bit tricky. It's the only one that wasn't set equal to 0. So I hope you figured out here that you were supposed to set this equal to 0 first. And notice this one's not a quartic. Instead, we've went back down to a cubic. So count the terms there. There are 4 terms. And so that should tell us the method here that we're going to use is grouping. And so out of the first group, I could factor out of x squared. That's going to leave me with x minus 2. On my second group, I could factor out of 7. So that'll leave me with an x minus 2. Now we can pull out that common factor of x minus 2. So we have x minus 2 times x squared plus 7. And now notice we have an x squared plus 7. Notice that's not a difference of squares. So that's not going to factor there again. So let's just see what makes both factors 0. So the first one here is going to give me a solution of 2. Now the second one, again, with my squared factors, I'm going to take the time and set those equal to 0 to c. I'm not going to try to do that in my head. So subtract 7 from both sides. That's going to give me negative 7. And so now we take the square root. And so that's going to be plus or minus I square root of 7. Okay, number 8. Now this is a similar one to number 7, except for it's already set to 0. So what I've got to recognize there are 4 terms. And so I can probably do this one by grouping. So my first group, I'm going to factor out of x squared. That's going to leave me with x plus 3. Out of my second group there, I can factor out a negative 6. And so that'll leave me with x plus 3. And so let's pull out that common factor. So x plus 3 times x squared minus 6. So notice that's 6 there. So that's not going to give me a difference of squares. If I had maybe 9 or 16 or 25, I could maybe have factored that again. So let's see what makes them 0. So the first solution there, what makes that 0 is negative 3. Now just like the other one, we're going to set this equal to 0 since it has a squared term. So this is going to give me x squared equals 6. And take the square root of both sides. So we'll get plus or minus the square root of 6. Okay, number 9. Now, let's notice this one. This is really not a quartic or a cubic. It's really a quadratic. And so we call this one quadratic-like because it is still a quadratic. But the idea here is we're going to use that substitution. So we have that x minus 5 there coming up twice. And so what makes this an easier problem to do is just let a be x minus 5. And so if I substitute a in place of x minus 5, I get an easier equation here that says x squared minus 3a minus 28 equals 0. And so this one's much easier to solve. So factors of 28 that subtract to give me 3 now is going to give me 7 and 4. Signs are different. It's going to be that first minus on 7, and then the 4 would be positive. And so we get solutions there for a to be 7 and a to be negative 4 to make them 0. Now, that's not the solutions to my equation. That was a variable a that I sort of introduced or, kind of made up there. So what I need to do is to find x. So recall that x, or that a was x minus 5. So I'm going to say that x minus 5 now equals 7, and x minus 5 equals negative 4. And so this is going to give me a solution here of 12. But add 5 to both sides. Add 5 to both sides here. Negative 4 plus 5 would be positive 1. I was going to say negative 1. That was wrong. Okay, number 10 is another similar problem here. Again, I'm going to see that we've got those parentheses. That kind of gives away that substitution idea, is you'll see those parentheses in those problems like that. Now, what's a little bit different here is this is actually a quartic, because it's y squared here, squared. And so I'm probably going to come up with 4 solutions to this. Now, we're going to let a here again be what's in those parentheses, y squared minus 1. And so that'll give me a squared minus 9a plus 18 is equals 0. So that's much easier to solve. Now, factors of 18 that add to give me 9 would be 6 and 3. Signs are the same. They would both be negative. And so a would be 6, and then a would be 3. Now that's a. I need to find out what y is. So I'm going to recall that a was equal to y minus 1, or I'm sorry, y squared minus 1. So we're going to have y squared minus 1 equals 6, and then y squared minus 1 equals 3. And so I'm going to add 1 to both sides here. That's going to give me y squared equals 7. And then take the square root of both sides. So we get y equals plus or minus square root of 7. That won't simplify. Add 1 to both sides here. That's going to give me 4. And then take the square root of both sides there. Square root of 4 is going to give me plus or minus 2. So notice that's 4 solutions there. Okay, number 11, kind of similar. This one's actually a little bit more complicated. In this time we have the y squared squared again, but this time we have y squared plus 6y. So these are going to turn into 2 harder quadratics after our substitution. So we're going to make the substitution here and let a equal y squared plus 6y. And so that's going to give me a squared plus 14a plus 45 equals 0. Now factors of 45 that add to be 14 would be 9 and 5. And so my values of a are going to be negative 9 and negative 5. Now that's a. I'm looking for y, so I need to put this back in here for a. So a is equal to y squared plus 6y. So y squared plus 6y equals negative 9. Same thing here, y squared plus 6y equals negative 5. Okay, so I get 2 more kind of complicated quadratics. They're trinomial ones. So I'm going to try to factor them. If they don't factor, you can always maybe complete the square or use the quadratic formula, but I think they're going to factor here. So on this one, factors of 9 that add to give me 6 would be 3 and 3. It's actually a perfect square trinomial. It's really not important though. We could just do this. And so that's just going to give me one solution out of that one, which is the negative 3. Now on the other one here, let's bring our 5 over so we can set it equal to 0. Yeah, and that will factor. Factors of 5 that add to give me 6 would be 5 and 1. I think earlier we've done one there where it didn't factor. And so if it does not factor, we can complete the square or do the quadratic formula. It's not that we couldn't do it, it's just we'd have to use a different method. And so now solutions from this part of it's going to give me negative 5 and negative 1. Okay, number 12. Right now we sort of switched again. Now we're back down to a cubic. So what I'm going to look at there is I've got 4 terms. So when I see that, my mind has to think, hey, grouping. So I'm going to factor out y squared there on that first group. That's going to leave me with y plus 2y. I can factor out a negative 9 on my second group. Well, wait, back up. That's going to be y squared times y plus 2. And on my second group, factor out a negative 9. So that's also going to leave me with a y plus 2. So let's factor out the y plus 2 now. So I have y plus 2 times y squared minus 9. And notice this time, unlike the other ones that we've seen from this sheet here, this will factor again. That's a difference of squares. So we can have y plus 2 times y plus 3 times y minus 3. Now let's see what makes them 0 here. So we're going to get y to be -2, and then -3 from that one and +3 from that one. So I'm just going to say plus or minus 3.